Okay, so hopefully this little video I make here helps you finish today's diagram. I'm sure some of you could probably knock it out without watching this, so feel free to use it as you see fit. But if you do spend about 10 minutes watching this, you should be able to get today's diagram done as you watch it, and then you could use the rest of your time to finish what you didn't finish yesterday, or just make it look good enough so that we could hang it up on the wall. So you should all have a diagram in front of you that states exactly how to earn 100% on this assignment. The first thing you're going to want to do is make sure you have a caption, which states the cause of all waves and what they carry through space. So how waves are caused is a type of motion. We covered that last week during the simulation, and it is in your pretest. Think about how you were able to get a wave going through the slinky. That should help you fill in this blank space. The next line, what waves carry through space, that's another thing on your pretest, and we've been talking about this for quite some time. So hopefully this is easy points for you. Okay, the next thing we're going to have to do is start illustrating. We're going to make sure that our wave has a high and a low point. And then we're going to want to label it with the word and definition. The definition for each of these is pretty much given to you in the rubric. So I'm pretty new at using this drawing app, so hopefully it looks good enough for you to learn from. You could also use Google Documents to make one of these. Okay, so I've made my illustration. Now I want to label the high and low points. Here's a high point of a wave right here. You want to label this. And here's a low point of the wave right here. Label that. Now I'm not going to give you what these are. You pretty much did this yesterday on your reading notes. But just write a word here, and then underneath that you should give me a little description, which I told you is already in the diagram. This is the high point, this is the low point. Okay, so the next 2 points is to illustrate, measure, and label the distance between two high or two low points of the wave. If I drew my wave properly, this should be the same distance from here to here, should be equal to the distance from here to here. So let me show you first what I often see students doing, and this will cause you to lose points on this assignment and on the quiz. A lot of students write this right here as the wavelength, from here to here. So this isn't quite the wavelength, it's almost the wavelength, but this will be the loss of a point. So get rid of these two. The wavelength is going to have to be the distance from this point of the wave to this point of the wave. This is your wavelength here. So I'm not going to write the whole word. I'll write the symbol for wavelength. And we want to write the measurement. So here this goes up to about 6 centimeters where this line starts. And over here it goes to about 14 centimeters. So 14 minus 6 is 8. So this distance is about 8 centimeters. So don't forget, you're also going to want to write down what this is, the wavelength. Oh, and define it, the distance between two high points or two low points. Okay, so the next thing that you need to do is illustrate, measure, and label half the distance between the wave's high and low points. So here's the high point, here's the low point. Half of that distance is going to be your amplitude. So this distance is also the distance from the resting point of the wave to the high point or the low point. So the resting point would be, or the resting line would be where this medium would be, whatever is excited, if it wasn't excited, if there wasn't any energy in the system. So just draw this resting line, it's a dashed line right through the center. And the amplitude would be the distance from the high point to that resting point. It would also be this distance here, or this distance here. So using the measurement tools on this thing, that is about 6 centimeters. This is about 10 centimeters. So this distance right here would be about 4 centimeters. So make sure that you draw this line, you label the length of that line, and you tell me what that line measures, which is the amplitude. And you should also have a little sentence that says half the distance from the crest to the trough, or the distance from the crest to the rest. I should probably put that over here as well. Okay, the last 2 points, you're just going to choose 2 values. Actually, don't choose your speed. First, choose your frequency. So the frequency of your wave needs to be given, and you need to give your speed. But since we're going to show how these relate to wavelength, and that's a mathematical relationship, we want to be strategic about our choice. These have to fit into an equation, and that equation was given to you last Tuesday. So we'll do speed last. Let's worry about frequency first. So the frequency of our wave, let's say 4 hertz. So that's 4 cycles per second. So for every 1 second, this wave will go through 4 cycles. So there is a relationship between frequency, wavelength, and speed. We saw this last week. Speed is equal to frequency times wavelength. So that means that the speed of our wave is going to be equal to 4 hertz times 8 centimeters. Now you can convert this to meters if you wanted, or we can just put our speed in centimeters per second. So let's plug our numbers in to get our speed. 4 hertz. Now instead of writing hertz, I'm going to write what a hertz is. It's the inverse of seconds. I'll multiply that by my wavelength of 8 centimeters. Four times 8 is 32. Centimeters times 1 is centimeters, divided by seconds. So this wave would have a speed of 32 centimeters per second. Okay, so the last thing that you want to do is make sure that somebody else takes a look at this before I do. Now if you do this on Google Docs, which you can, oh, you don't want to see that. I had a page up here for you. Remember, you can insert, go to the drawing app, create your own curve, make it look a lot better than mine. Might take you a little bit longer than putting it on paper, but I will grade it a lot faster if you do that. if you want to do it on paper, it will get graded before spring break, and if you put a lot of effort into it and you get 100% and it's colorful, we'll put it up on the wall. So just make sure that before you decide that you're done, you make sure all of these components of the rubric have been met. All right, hopefully this was helpful for you. Have a good day.